Hello everyone, this is Ms. Page. In this lesson, which is the third lesson in our Unit 3A on polynomial expressions, we are going to look at problems where we're going to model situations with polynomials. And we will use the skills we have been developing in the first two lessons where we will combine polynomials through our operations of addition, subtraction, multiplication to create a function for the situation. So our objective is that students, we will be able to model real-world situations with polynomials. So you are now, of course, you learned about polynomials last year. You're learning more about polynomials this year. So you're going to find that some of these problems anyways will be a little bit more grade appropriate to where you are now as juniors and seniors, and you're looking at a little bit more reading going on for the situation. So that's where I would say we always begin, is by reading the problem, using our highlighters, our pencils and pens to denote or annotate the key parts of the problem. So we have the data from the U.S. Census Bureau for 2005 to 2009 shows that the number of male students in thousands enrolled in high school in the United States can be modeled by the function m of x, where x is the number of years after 2005. The number of female students in thousands enrolled in high school in the United States can be modeled by the function f of x, where x is the number of years after 2005. Here is what our task is. We are to write a new function named t of x that models the total number of students in thousands after 2005. And you'll notice that kind of all goes along with our information in the problem. For example, we know that male students is in thousands, and that it's represented by this function here, m of x. We know that female students is also in thousands, just like it said in our t of x, it's going to be in thousands, and that is represented by f of x. We also know that x in both m of x and f of x is defined in the same way, the number of years after 2005. And that's actually necessary for us to be able to combine those two functions into a new function here called t of x. So now the question is, based on the concept, what's the mathematical relationship between m of x and f of x that will allow us to create t of x? So what does t of x represent? So t of x models the total number of students. So in that context, we should understand, well, the total number of students would be the male students plus the female students. So what we are going to do to create our t of x function is we are going to take our m of x, which is this one right here, and we are going to add to it the f of x like terms. So I'm going to line up my like terms here. Hopefully I can do that. It's looking good so far. Now, if you're thinking, whoa, these are some big numbers, you are allowed to use a calculator here, all right, to speed up the process when necessary, because we're dealing with more realistic types of functions that involve bigger numbers, might involve decimals, all that kind of stuff. So it's not about the basic skills at this point, it's about the concept and the application of our skills to write the function. So here we now add, so this is going to give us, and don't forget that your new function needs to start with t of x equals, or it's not a function. It doesn't have the name that's required. So this is going to give us negative 23x cubed plus 129x squared plus 138x plus 1,620. And there is our function that models the total number of students in this situation. All right, let's move on. So there's a part B to this problem, and part B, our task is to estimate the total number of students enrolled in high school in the United States in 2009. So here we have to realize, okay, well, the total number of students is represented by the function we just wrote, which is t of x. And to figure out the actual number of students that that model would give us, we need to have a value for x. Remember, x is defined as the number of years after 2005, and we're looking at the year 2009, which means that our x value would be the 2009 minus the 2005, or a value of 4. So now we're looking at finding t of 4. So t of 4 is going to give us negative 23 times 4 to the third power plus 129 times 4 squared plus 138 times 4 plus that 1,620. And so now we can use our calculator to help us speed up this process. So hopefully you're doing this with me to test your calculator skills and make sure that you know how to put everything into the calculator to get the right answer. So hopefully if you're doing this with me, you came up with 2,764. Now, here's again where really paying attention to and evaluating our answer and seeing if it makes sense in terms of the context is super important, because if you decide that that's your answer, unfortunately you would be wrong. Because remember that each of the functions m of x and f of x, they model male and female students, but they do so in thousands, which means that if we got an answer of 3, it doesn't represent 3 male students, it represents 3,000 male students. Which means that this 2,764 does not represent the total number of students in this situation. We have to first multiply it by 1,000, which would add 3 zeros to our number. And so we're looking at 2,764,000. And so now what we're looking at now writing a conclusion. So for your context problems, you will be expected to interpret the math in terms of the situation, write a sentence conclusion. So remember, this is an estimate apparently. So we can say that this is an estimate, or we can say about, if we want to, in the problem, total number of students enrolled in high school in the United States in 2009. So I'm going to say in 2009, the total number of students. Notice I'm using the question or prompt to pretty help me write my conclusion here. Enrolled in high school in the United States, because other countries have high schools too, is estimated to have been, because this is in the past, 2,764,000. So that is our end goal, is a conclusion, something like that. All right, let's move on. All right, so here we are again looking at another kind of wordy problem. So again, I'd read it, annotate it with highlighters, pens, pencils, that kind of a thing. So reading it, it says the data from the U.S. Census Bureau for 2000 to 2010 shows that the total number of overseas travelers visiting New York and Texas can be modeled by the function t of x, where x is the number of years after 2000 and t of x is the total number of travelers in thousands. The number of overseas travelers visiting New York can be modeled by the function n of x, where x is the number of years after 2000, n of x is the number of travelers in thousands. Our job is to write a new function f of x that models the number of overseas travelers visiting Texas in thousands after 2000, the year 2000. So, all right, let's take a look at what we know. So again, our t of x, remember, represents the total number of overseas travelers visiting both New York and Texas. And we know that n of x here is representing New York, overseas travelers visiting just New York. So when we go to write our new function here named f of x, we need to make sure we understand the mathematical relationship between t of x and n of x that will give us f of x. So f of x is going to be what we're looking at, visiting Texas. Okay, so we've got T of X is New York and Texas. Think of T is total, and F of X being just Texas, which would be what's left over if we take away those travelers who attended or visited New York. So we are looking at subtracting. So our F of X, our new function named F of X, make sure that you understand the subtraction order here. You need to take the total, which is your T of X function. And then from that, you are going to subtract the N of X, which is New York, and get New York people out of there. All right, so remember with subtraction, before we combine any like terms, we want to apply the subtraction concept of adding the opposite. So I want to make sure that I make this addition, and then each of these terms here will change signs. So this becomes positive, 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 and negative. And now I'm going to get my new function f of x, and I am going to get 82x cubed minus 129x squared plus 595x minus 404. And there's my function. So in this case, no conclusion, because write a new function was my task, and I did that. I don't have to interpret that. All right, let's move on. So here, part B is a practice problem for you to try. So I would encourage you to pause the video here and do the math, see if you can see what conclusion you come up with, and when you're ready to check it, come on back. All right, let's take a look at the result, what we should have gotten here. So using our function f of x from part A, you should have determined that x would be 8. And then plugging in your 8, you should have gotten 38,084. And then again, hopefully you realized that T of x and N of x in the original problem represented quantities in thousands, which means so does f of x, since it's created using T of x and N of x. So you have to multiply by 1,000, and so we get about 38,084,000 in this case of visiting. That should be Texas. Apparently there was a change here, and somebody didn't change that part. All right, let's move on. All right, this next example now. Here again, I'm going to read it, going to annotate with the key information, look at what my task is. So a straight section of a biking path has a width in feet modeled by the function w of x, and a length in feet modeled by the function L of x. My task is to write a new function P of x that represents the perimeter of this section of bike path. Okay, so I know that my width is in feet, and it's w of x, and I know that the length of this section is also in feet, and it's my L of x function. What I now need to know mathematically is based on what kind of shape would I have. So realizing that if it's a straight section of biking path and it's got a width and a length, it's going to look like a rectangle, and I want to then mathematically I need to know, well, how do I find the perimeter? So I need to recall that to find the perimeter I would add up all four sides, and I have two sides that are lengths and two sides that are widths. So there are different ways that I can look at this. I could just add them all up four individually, or I could do a shortcut where I can multiply each of them times 2 and then add those quantities together. You may also recall that you could add the length and the width together first and then multiply that times 2. So I think I'm going to use this one. I think it might be a little easier and faster for this problem. All right, so first thing I'm going to do is I am going to add the length and the width together, and that would be equivalent to half of my perimeter. So I am going to take that x cubed 4x squared, 5x minus 6, and add to it the 2x plus 7. And that is now going to give me x cubed plus 4x squared plus 7x plus 1. Now I'm going to multiply that times 2, and that will now take me the rest of the way to finish my perimeter. So I get 2x cubed plus 8x squared plus 14x plus 2. And don't forget, it's a function. So make sure it starts with the name of the function here of p of x equals to finish that problem. All right, let's move on. So here we've got a part B to this problem. We're going to do this together. Part B says find the perimeter of this section of bike path if we know the width is 17 feet. Now, what can happen to people in math problems is that they make assumptions they shouldn't make. Like, for example, making the assumption that whatever number you're given automatically or must represent the variable of x. And we have to realize here it doesn't, because x is not the width. X is something else. The width, remember, is w of x. So what we know is w of x is equal to 17 feet. Which means that 2x plus 7 is equal to 17 feet. So our x, solving this little equation, is actually equal to 5. And so we have to be careful. Always be carefully reading when you're doing math problems to make sure that you don't make careless mistakes like that. So now I would take my perimeter function from part A, and I'm going to evaluate it for an x value of 5. So I have got 2 times 5 cubed plus 8 times 5 squared plus 14 times 5 plus 2. And again, if necessary, you could use a calculator on this, and we should come up with a total value of 522. So again, this is something that represents a quantity in context, so we need to interpret it. So we have to realize, okay, the 522 represents the perimeter of this section of biking path, and its units of measure must be in feet since length and width are in feet. So the section of the biking path has a perimeter of 522 feet. And you could abbreviate feet as long as you use the appropriate abbreviation of FT. All right, let's move on. So here we have a problem. It says Mr. Silva manages a manufacturing plant. From 1990 through 2005, the number of units produced can be modeled by n of x. Think of n as number of units, where x is the number of years since 1990. The average cost per unit in dollars can be modeled by c of x. Think c for cost, where x is the number of years since 1990. So we're supposed to write a function, t of x, that can be used to model Mr. Silva's total manufacturing cost for those years. So remember that the c of x isn't total cost, it's average cost per unit is c of x, which means, like, on average, let's say that he was making plates. That means on average each plate cost c dollars, where c is like c of x. So that's like the average cost for one plate if our units were plates. And then the number of units, like the number of plates produced, is modeled by n of x. So if we had 30 plates and they each cost a certain number of dollars, to figure out the total cost, hopefully we'd realize that the mathematical relationship there would be multiplication. So we are going to have to figure out t of x by taking our n of x and multiplying it times our c of x. All right, so Here we're looking at I'm going to first distribute the way I've written it, my 20x squared. That's going to give me negative 40x squared plus 200, oops, not x squared, oopsie, x to the fourth, 2 plus 2, shame on me, be careful, you can do it too. So then we're going to get a 200x cubed, and then the 20 times the 200 is going to be a 4 with 3 zeros, so 4,000x squared. So now I have to distribute my 20x. So that's going to give me negative 80x cubed, so I'm going to put it here. And then a 200x squared. And then that's going to give me a 4 with 3 zeros, so a 4,000 with an x. All right, and one more time. Now I'm going to distribute my 3,000, so that's going to give me a negative 6,000x squared. So I'm going to put that here. And then I'm going to get a 3 with 4 zeros. So that's 30,000x. And then I have a 3,000 times a 200, so that's going to give me a 6 with 5 zeros, which is 600,000. I'm going to combine my like terms, and after all of that work, I don't want to forget my t of x equals, so I'll start with that. All right, so I've got this negative 40x to the fourth plus 120x cubed. And I have to say, wait a second here, because I just caught a mistake. If you caught my mistake from earlier on, congratulations, yay for you. So this is why you've got to be careful and double check your work. So I'm looking here at when I distributed my 20x to my negative 2x squared. For some reason I said 20 times 2 was 80 instead of what it really is, which is 40. So that should be a negative 40x cubed. So that means that this value is going to be a 160x cubed. Now we're good to go. This is going to give me a negative 1800x squared. And this is going to give me 34,000x. 34,000x is correct. Plus 600,000. There is our new function. All right, let's move on. So here is a part B that we've set up as a practice for you. I encourage you to pause the video here and then come back when you're ready to check your answer. All right, so hopefully you came up with the same answer that I have here. Your x should have been 10, and then you're evaluating t of 10 for total manufacturing costs, and that came up to 520,000. So a conclusion similar to mine that includes all the necessary information. Mr. Silva's total manufacturing costs in 2000 were $520,000. All right, that concludes this lesson, and I hope you have a wonderful day.